Welcome, good. Okay, so now most people use the picture here. This is what I advocated in class last time. Right? You do the picture with the 2 points and you do the triangle and stuff. Okay? So that's good. That's good. That's what I want you to do. Now, you might have forgotten a couple of details. So let's just say that my points are 4, 13, and 18, negative 5. And that's what they're going to look like, and a lot of people have graphs that look a whole lot like that. With different numbers, because people have different numbers. Then we draw the fundamental triangle, meaning we draw the straight line between the points. And either above or below, we sketch the rest of a triangle with sides parallel to the axis, right? Now, one thing I didn't see, and you really want to be careful about this, is arrows that indicate what direction you're moving from one point to the other. Because if you don't, and some people didn't, and then got the right numbers but didn't have the right signs on it. So you got a positive result when obviously it has a negative slope. Okay, so I've seen that in a couple of papers. So you want to be careful about that. It's easy to fix. Just draw the arrows that take a path from one point to the next. So we always know what direction we're moving in. Now, moving along this path, rise. And you want to label this. You want to put this on your triangle, right next to the 2 sides, okay? And remember last time I said you really want to do everything that you saw me do. And I didn't see anybody doing all of that, but a lot of you did most of it, and you have the idea. I really recommend that you label these things completely, as you've seen me do. You do that if you need to. I'm going to do it again. But it'll benefit you. It'll help to keep things straight, especially when you get into having to do these symbols. Okay. So the rise is changing the y coordinates because, of course, you have changing y coordinates here. And that's where you end up with, which is at -5, minus where you start, which is at 13. That's -18, and obviously your rise is negative here. If you do the arrows, you see that. Now you might have chosen to do your arrows from here to here, in which case your run would be negative and your rise would be positive. You don't have to go left to right, but that's kind of the standard thing. So if you got a reason to go right to left, just make sure everything goes right to left. Make sure that your path goes from the same point to the same point. Make sure this path goes from the same initial point to the same final path as this path. Okay. Now, the way I've done the paths, which is the traditional way, there we have it. Okay. Equally valid the other way. So you can make your choice. Now, from here to here, you run equals 18 minus 4, which is 14. So the slope, I want to write it out. Keep reinforcing it. Is rise divided by 1, which is -18 over 14. That's equal to -9/7. And then everything is here so that I can see it when I look at it. Somebody else can see it when they look at it. You have this over here, but I don't want to read all that. Okay? Neither does anybody else. Unless I think there's a mistake, then I want to be able to look at it and see what you did to make that mistake. Okay? But what I want to see is in a box here, right next to the hypotenuse of this triangle, -9 over 7. So now I can see, okay, you think the rise is this, the run is this, you think there's a slope, and that seems to be right. And right there's your documentation in case there's a question. That makes sense? That's how you communicate your solution. Okay, that's a shorthand communication. You don't have to write a paragraph. So if you write all that, then it's clear what you did and how you got it. From the arrows, it's clear that, okay, you're thinking, you know, a path from one point to another. Okay, there it is. Okay, here. I'm going to make a statement over here. Not a very precise statement, but it's kind of where you start. The average rate of change is a change in one thing divided by change in another. It's a change in this divided by change in that. Okay? This is the average rate of change. Of this. With respect to that, which was the name I ever wrote. Okay. So, what's this in this case? Okay, well, you want to slow to answer, maybe just because you're not used to answering. I think most of you understood, but what's this and what's that for this situation? Okay, that's what this was, nobody told me. So that's what that is. That is easy to identify because it's a thing they do in the change with respect to. Now, unfortunately, your book doesn't use the terminology with respect to. They just say the average rate and expect you to understand all that, which I expect you probably sort of do. Okay. However, it doesn't prepare you as well for calculus as it should, because the most important concept in first semester calculus is rate of change of something with respect to something. And the with respect to is extremely important, and it also helps you identify what you divide by what, okay? So you'll see me use with respect to, and you want to think in terms of with respect to, and ask yourself, what are they really saying with respect to? Well, when they say the average rate of change of, the average rate of change of this, right? So it's easy to identify this. Okay. So for this problem, that is the time and this is the number in the hospital. So now average rate change in this divided by the change in that, okay, which is change in the number in the hospital, use pound sign for the number, and that is change in time. Well, what's the change in the number? Well, the number starts at 480 and ends at 360, right? It's what you end up with minus what you start with. Change is negative 120, not 120. Some use 120. Go first. Day after the assignment, that's not too bad, but you got to be very careful that if something decreases, its change is negative, right? So you want to be careful, and it helps to write these things out in detail so you really have it well defined, because then you build an understanding that's much more solid than the understanding you have when you just kind of vaguely subtract a couple of numbers and then get them in the right order. Okay? Some of you did that. Okay, so that's 360 minus 480. What's the change in time? Well, you're changing, the time goes from whatever time this is to 8 weeks later, right? Okay. So this is, let's say in my case, if A is 5. Okay. Then you want to maybe put some meaning on these things. I know it's a little hard to read. Just over a little bit with the watermark, but it's 360 patients minus 480 patients, right? So that's I'll just abbreviate patients as PAT, okay? And maybe PAT's one of the patients, who knows? Okay, divided by 5 weeks. I wrote that pretty clearly because it's getting small. Can everybody see it? Okay. And that comes out negative 24. Negative 24 what? Patients over weeks, which we read as patients per week. Okay. Make sense? So you want to do all that. You want to be in the habit of doing all that so that you're sure you're thinking clearly, and it really doesn't take that long. Okay? Go through those steps, reason it out, make sure you understand what the information is telling you, because that's an extremely important skill in most professions and in life in general. Okay? Okay. What about equations of linear functions? The equation of a linear function can always be put into the form. Am I recording? Yeah. Okay. Why is a linear function of x then for some number m and some number b? we have y equals mx plus b. M is the rate of change of y with respect to x. Going back to the example we just did, the average rate of change for the number of people in the hospital with respect to time, okay, this would be M for a linear equation, okay? And B is the value of y and x equals 0. Obviously, if x equals 0, mx equals 0, and y equals b, right? Okay. On a graph, y equals mx plus b. That is the slope. And that is the same for any two points on the graph. Points. And I'm going to put a word in there, distinct, because if I use the same point on the graph, you don't get a rise and you don't get a run. Okay? Can't use the same point twice in calculating the slope. Okay? That means any 2 points. And if you know 2 points on the line, it allows you to calculate the slope between any 2 points in the line. And B is the y-intercept. That is the coordinate of the point on the y-axis. Point of the graph that's on the y-axis. Okay. I could say more about that, but I'm going to choose it. If we go back to just a numerical example, the one that we started with, and same could be done with your numbers. If we put the point 413 on a graph, point 413 on a graph, with the point 18 negative 5, then we can draw a straight line. Not as straight as I'd like it, but there it is. Let's pretend it's straight. Okay. There's a straight line. The slope is negative 9/7. Putting a number in a box next to a line. Yeah, then that's a convention I'll use. It's not a convention that's done out there in polite society. But in this course, I want to use that. Okay? I want you to use it. Okay, well, there we have it. I just realized again. My fault. Okay. There we have it. Okay. Full statement, an example. And here's the y-intercept. This is the point 0b. Everybody? with me? Okay. Now, for this particular function, I'll just sketch it again in case the board gets separated. Here we have it. Okay. Now, y equals mx plus b. What's m? The slope, which we calculated using a fundamental triangle. Here. So there's a little more detail here and incomplete detail here. Okay. M equals negative 9/7. Y equals negative 9/7 x plus b. Okay. Also, 413 says that on this graph, y equals 13 when x equals 4. So 13 equals negative 9/7 x. 9/7 times 4 plus b. And we solved that for b. No, we did that last time. We did an example like this last time, didn't we? Was that in another class? Yeah, I'm seeing a little, not everybody necessarily recognizes it. So maybe I didn't do it here. Okay, well, okay, so we take this equation. And we bring this equation up here. 13 equals negative 9/7 times 4 plus b. We're going to go with my heuristic of we always multiply by the common denominator. So we don't have to deal with fractions until the end. So we get 7 times 13 equals 7 times negative 9/7 times 4 plus 7 times b. Every term has been multiplied by 7. And we get 91. Okay. Now, 7 times negative 9/7 means 7 over 1 times negative 9 over 7, which is the same as 7 over 7 times negative 9 over 1, which is negative 9. Negative 9 times 4 is negative 36. So we have this. And now we have 36 to both sides. And in one step, switch the two sides. We get 7b on this side and 127 over here. So we switch the sides, we get 7b equals 127. So the b equals what? Now, if this is 13, it looks like this is around, oh, maybe 21 or 22, right? According to my picture. So I better get something at least consistent with the idea that it's around 20 something, okay, in the low 20 figures. And it isn't. So close enough. B is 127 over 7. which is 18 and 1/7. So I said around low 20s. Well, I didn't look very well. And yeah, my picture probably wasn't that great. And I wasn't being that careful. But I made a kind of not very good estimate. And we get 18 and a 7. That's still reasonable for the numbers on the graph, right? Should just say that's around 20. Okay, that is. Okay, so now 0B equals 0, 18, 1/7. So if I know 2 points, I can find the equation of a line. Now, there's a formula for that. And I don't remember if it was in this class or another class, but I talk a lot about don't mindlessly use formulas because that doesn't give you any understanding. Use the picture and reconcile the picture with the formula. So you got 2 ways of looking at it. It's like looking at something with 2 eyes instead of 1. You get a little depth perception. Okay? So I much prefer to see the picture than just a calculation with a formula, because I'm not sure you're seeing any meaning in the formula. You might get the right answer. You don't understand the meaning, it's going to be less valuable to you. Accompany the picture with the formula. You should also know the formulas. I'm not saying you shouldn't use formulas. Don't use just the formula if you've got a choice. And in this case, you certainly have a choice. This is not an inaccessible task, okay? And it's something some of you were more or less doing. You did it in the wrong place, but you were doing it, okay? So I'm pretty confident you're going to be able to do it in the right place. Okay, I did say piecewise functions give some people trouble. And quite a few when they encounter them in open math, if we don't do a pretty good introduction. So I'm going to try to do that for you. Okay. Some people understand them right away. Some people, some really smart people, don't understand them well. Until things get clarified, and then it clicks, and there's always that. Okay, that's what it meant. Okay, so first of all, we finished this problem, which I hadn't quite finished. I got my value of B. I put it on the graph up here, but I never did write out the equation of the line, but there it is now. It's y equals mx plus b, but m is negative 9/7 from the fundamental triangle, and y is negative 9/7 x plus b. And y is 13 when x is 4, which gives you this equation, and you solve for b, and you get 18 in the 7. So now my y equals mx plus b is y equals negative 9/7 x plus 100.7 over 7. And that's the equation that represents the line that I just drew. Now, this piecewise function that we're going to define, we've already started defining it. It has a couple of definitions depending on what the value of x is. When x is greater or equal to 4, it's equal to this function. Okay. Now, I've already graphed that function all the way back to here and beyond this. Well, if x is greater or equal to 4, that means that my piecewise function follows the graph of this function, but only from here on. Okay. And let's say f of x equals 1 when x is between -2 and 4. Okay, including -2, but not including 4, because it already has a value when x equals 4. We can't give it 2 values. Don't you just have to have 1 value for x? Okay, so well, let's see. 1 is down about here. Let's just say that's 1. And then let's say that this is where x equals 4, -2 would be about here. And 4 would be maybe about here. So here, f of x is 1. Meaning y value is 1, right? And it's 1 when x is equal to -2, and it's not 1 when x is equal to 4. So I use a solid dot on -2 to indicate that that's part, that is a point on the graph of the function. But I do have the point for 1 here, but that's not on the function. So I put an open circle around it saying that point itself looks like it's part of the function, but it isn't. When x gets to 4, the function suddenly jumps up to 13, right? Now the function suddenly jumps to 13. Okay, then f of x equals, oh, I don't know, what do you want it to be? Let's say, I don't want to do that. Twenty over x. Why not? And, actually, I don't have enough room to do 20 over x down there. It'll be negative 10 over x when x is less than -2. Now, if you understand the graphs of the toolkit functions, which we did early in the course, and which I keep stressing, that's just your 1 over x function vertically stretched by a factor of 10. Okay. So when x is -2, of course, you can calculate that. It's going to be -5. You're going to have a point here. And then, well, you're going to have a point there, but you're not going to have that. Then the graph is kind of does this. Now, except maybe for the graphing of the 10 over x function. Remember the 1 over x function has a graph that looks like this and like this, right? And you should be very familiar with these graphs. As I said, you really need to be able to do all these graphs. You need to have done them a dozen times at least for practice, because they're fundamental to the course. So when I say we're vertically stretching the 1 over x function, you should understand exactly what I mean and why the graph has the shape it does. Okay? You really have to know these functions to be able to follow things that I'm going to be saying, because I won't always go into as much detail as I just did. Okay? But a vertically stretched 1 over x function, negative values looks like this because of what the original function was. Okay. Now, that's a piecewise function. Nothing real complicated about that, about the idea. And again, maybe the graphing of that function is a little fuzzy. But the idea that you could have 3 or more different functions on different intervals. Okay. So, something you need to know. Okay, I'm going to pause this. So to recap, line parallel to this line through this point has the slope -9/7 and y equals 15 when x equals 20. So we just write out what we know, just as we did over here, and we solve the resulting equation. We get the formula to we get the equation of the line, and it makes perfect sense that the y-intercept, which occurs when x equals 0, is 285/7, which is 40.5. Okay. This line intersects the y-axis up here. If this is 20, that's about 40. Plausible. Now, the other thing we can do, since we're having so much fun, how about the line perpendicular? we'll do the line perpendicular to this line to the same point. In 2015. Okay. Here's the basic principle. The line has slope M. Perpendicular line. Is reciprocal. And it's negative reciprocal point. Well, let's look at -1 over. Equal. -1 times -7. Which is 7 months. You understand how you understand that calculation. That's all right. Watch this 9 seconds. Let's see. What was 15 and that's equal to 20. Now, 9. Equation is 7 9 x minus 5 9. Now, there's a little bit of a problem with this graph because perpendicular doesn't look like it would come down below the x-axis. It looks like it hit about here. That's because I don't have equal scales on my X and Y axis. Okay, 18 here is about this big. And 18 here is about this big. This 18 is a little bigger than this 18. Okay, if the scales were equal, then it would be very plausible that the perpendicular line, find a good color, I guess, would go through like -7, 9. Okay, and this should be a right angle. It isn't quite because, again, I didn't bother to make the scales equal. Okay, I didn't know I was going to be using this to do the perpendicular lines. Could have planned that out, but it was a convenient thing to do. Okay, so where did I do it? This graph is this line, which is parallel to this line. This graph, purple graph, with 9/7 x minus 5 miles. Slope of 9/7 makes sense. That's a positive slope, pretty close to 1. 1.3. Okay. So that's a picture. Parallel and perpendicular lines. But the math will help reinforce that, but that should give you the concept. Okay. Say y is proportional to x means y equals kx. Okay, doesn't change. If y is proportional to x and y equals 4 when x equals 9, then 4 equals k times 9. And that's a tough equation. You can solve for k. If you divide by 9, that's easy, right? Get k equals 4/9. So now you have the linear equation y equals 4/9 x. So if I now say, okay, what's the value of y when x equals 700? We can plug in 700, take 4/9 of it. That's what y is going to be. Very simple. Now there's several kinds of proportionality. There's an inverse proportionality. Means y is not equal to k times x. It's k divided by x. In other words, a graph of y versus x would be a vertically stretched 1/x graph. Okay? And you should understand that because that's a function you know. Maybe you understand vertical stretch. If you do, it's something that you got to keep coming back to. Okay? And this means that when x gets bigger, y is going to get smaller, right? You divide by a bigger number, you get a smaller result. If I give you the values of x and y, you know, value y when x equals something, okay? then you can easily solve for k, and you can do the same thing we did over here, except it'll be some number divided by x. And that's going to be your rule. Okay? Very easy. Very easy. As long as you're a little bit careful and pay attention to the details, okay? So you do have that assignment. It's an important idea, very important stuff, okay? And there are other proportionalities. You could say y is proportional to x squared. Well, that would be y equals k x squared. Y is inversely proportional to x cubed. Well, that's y equals k over x cubed, okay? It's actually very simple once you sort it out. So people usually don't have any trouble with that assignment. So I'm kind of leaving it to you to tease it out from the examples and everything. They'll tell you the same thing I'm telling you, but in different words, okay? So that's